And then the last two, I'm going to do them both kind of at the same time. At least I'm going to fill in the information that we know just from the diagram. I'm going to do that together on both of them before I solve it completely. So the first thing to do, I always like to do, is pick out the angles that we have information about from the diagram. So if you look here, that's angle A, there's nothing there. That's angle B, there's nothing there. Angle C is 90 degrees. Great, let's go ahead and put that here. There's angle A, there's nothing there. Angle B has a 24 there, so I know that's 24 degrees. And then angle C, well, has the square, so I know that's 90, right? And then we're going to go through and find any side measure that's given. So I'm going to label the sides first. This one is C, and I'm only going to put a letter on the sides I don't have anything on. Like this one is C. So C I don't know. A, so imagine I'll draw this line from capital A and it goes across the triangle. So from capital A down here to 5.8, that's the opposite side. So 5.8 is lowercase a. So I'm going to put that in here in my lowercase a spot. And then this one must be B. And you can tell it is B because if you start at capital B and then go across, you touch here. Again, I don't want to draw too much inside my diagram, so I'm just going to imagine we draw a line from capital B to lowercase b. And the same thing over here. This one is lowercase c. Across A is lowercase a. So again, across A would look like this. And then 13 must be B. Okay, because that's A, that's C, that's B. Again, I know it is because if I draw a line from capital B and go across, it touches the 13B. Okay, so that's all the information we can pick out from the two diagrams. And it's actually a lot. It's half of what was missing. So then let's go through and find the rest. Now earlier I mentioned the Pythagorean theorem, and that's actually what we're going to use to solve this triangle. Whenever we have two sides given, I like to use the Pythagorean theorem to figure out the third side. Okay, so A is 5.8. Let me lower this a little. A is 5.8. B is 8.9. And then C, well, C is the one we're looking for. I'm going to kind of save some time and type it in together. I know it's 5.8 squared plus 8.9 squared. Well, the good thing about the calculator, using a calculator, is all of this can be typed in at the same time. Now that's only the case when we have both A and B. The other times we need to subtract the two. So anyway, when I type that in, I get 112.85. Okay, and then remember the last thing we need to do is take the square root of both sides. So we have C equals, and then type in square root 112.85, close the parentheses, 10.6. Okay, 10.62. Again, I'll do that rounding thing with you guys. So this is the number we round to. Because that is less than 5, I'm not rounding it. It's going to stay at 10.6. It's not bumping it up. Okay. So then next it says, okay, well, let's find angle A or B. Let's find angle A or B. I don't have information about either one, so it doesn't matter which one I choose. I'm going to choose angle A. I'm going to choose to solve angle A. Well, if I'm using angle A, I know this side that's across from it is the opposite side, and this side that's next to it is the adjacent side, because this one's the hypotenuse. That's across 90 degrees. And then again, you go back to your trig ratios, and say which one uses opposite and adjacent. And I know the trig ratios, opposite and adjacent. There it is. It's tangent. Okay, tangent is opposite and adjacent. So I can write this equation: tangent of angle A is equal to the opposite side divided by the adjacent side. Again, because we're finding these angles, I said we need to use the inverse function to get rid of tangent. Tangent, inverse, and tangent cancel, the A drops, and then this we can go ahead and type in the calculator. Let's type that in. Second tangent, that's the tangent inverse, and then we just type in the calculator, the fraction into the calculator. 5.8 divided by 8.9, close the parentheses, and that gives us 33.09. So let me type that in here, or write that in here, 33.09. Okay, again, this is the tens place. This is the number we check. Because it's bigger than 5, it's going to bump that up. So that's going to be 33.1. And then finally, the last thing we do is take 180 and subtract these two, 90, and then 33.1 to find angle B. It's going to be 180 minus 90 minus 33.1, 56.9. And those are the three angle measures and the three side measures. Okay. So now let's move on to this one. Figuring out the sides is easy over here. I already have two of them. I can just subtract out the two I know to figure out the one that's missing. Angle A is the one missing. So I can do 180 minus 24 minus 90. Can't see that, but it's 66. And then we need to find side A and side C. So let's identify an angle we want to use. Now again, it doesn't matter which one we choose. Let's say I want to keep using A. I want to keep using A. And I can, because even though it doesn't have the number there, I know what it is. It's 66. So let's keep using A. But I do need to put 66 up here. That way it reminds me what that angle is. Okay. And since A is 66, I know this side is the opposite side. This side is the hypotenuse. And the 13 is the adjacent side because that touches A. It's adjacent to angle A. So let me go ahead and write adjacent. And then between A and C, let's go ahead and find A first. A is opposite over adjacent. We just went over that one. That's tangent, right? Opposite and adjacent is tangent. So I'm going to say tangent of this angle, which is 66 degrees, is equal to the length of the opposite leg divided by the length of the adjacent leg. That's simple. Set it up as a proportion. Cross multiply so you don't grab the letter. Divide by what's left over. Type that in the calculator. When we type it in the calculator, it'll look like this. Tangent of 66 times 13. Remember, type in what's in the bubble first, and then divide it by 1. So we get A equals 29 point. Man, all of these are rounded. Again, this is the tens place. That's what we check. It's more than 5. It bumps up. So little a is 29.2. And then I'm going to cover little a. I'm done with that guy. Then say, okay, we have adjacent and hypotenuse. Hopefully I don't need to go back to my trig ratios. But adjacent and hypotenuse is cosine. So cosine of this angle is equal to the adjacent side divided by the hypotenuse. Yeah, it doesn't matter where the variable is, it's still easy to solve. Write it as a proportion. Cross multiply so we don't grab the letter, and divide by what's left over. Now when we do this, again, make sure you type in what's in the bubble first. 1 times 13, and then divided by what's left over. Cosine of 66. C equals, oh, be careful with this one, 31.96. This one's tricky because that's the tenths place. That's the number we check. It's actually going to bump this up 9 to 10, which is going to bump this one over. And it's going to, all of this ends up rounding to 32.0. And that, oh man, there you go. That's what I was talking about. That's it. That's the answer.